Hi, this is Ed from OptiSurface, and I'm going to show you how you can use AgEarth to do water analysis on your drone deploy data. So, drone deploy generates the TIFF file, which imports directly into AgEarth. You can click here and navigate to the folder where you have the TIFF file saved. Open that, and yeah, you will be asked to select which unit you prefer. So this is in the US, so I'm using fit. And yeah, we would recommend to trim down the points to 100,000 points, but we have had success with more points, say maybe 200, 300,000 points. So yeah, we can skip this and select one so it doesn't skip points. Then hit OK. And yeah, it will load the data and load the background image. And you will see it's all black. This is simply because of the points. When you turn off the points, yeah, you will be seeing something like this. So you can adjust the size of the points with this. Let's say 0.5. Yeah, so we can see the surface as well as the points. And next is, yeah, you want to confirm the location. So yeah, it looks good. And let's adjust this boundary so it just covers the edges of our area. And next is, yeah, for the topography, we can adjust the legend to show more colors. So let's try that. You can move here. The minimum is around 353. And let's say 2. Yeah, I think that's good. We can see the trees in there and these structures, buildings. So yeah. Um, the next step would be to trim out those trees in. So we have a tool here called this one, remove spikes. You can play around with this. This could be a good initial um, trial for this. And yeah, it's not perfect, but it will save you some time. So let's use the default. Let's say just a max iteration of say 20, and let's apply. So you can see it's slowly trimming things. So yeah, if you find that acceptable, yeah, you can hit apply or close actually. If you hit apply, it will do it again. Or if you're not happy with it, you can hit undo last. But I think this is good, and yeah, I will close this and now do it manually. So what you can do is use this tool, select points, and draw in the area you want to delete. So delete points. Yeah, that gives better representation, I think. And yeah, we will do it for the entire area. Okay, so I have manually deleted most tree points in here. So yes, looks something like this. It's not perfect, but yeah, at least we have removed most of them. And the next step is to run the depression analysis. So you can click here and yeah, it will simulate. You can adjust the grid sizing here. Let's set this to say 15 and restart that. So yeah, you can see how water flows out. You can um, change the colors if you wish. And yeah, next is the storm analysis. So for the storm analysis, you will need to have the rainfall data. Click here and select Cox storm, and you have to determine the um, 1 hour total rainfall. For we usually use a storm event for a 1 in 10 year storm event. So yeah, let's find that out. What you need to do is go here, click here, tools, and open this field in Google Maps. So that will show you where it is located. So it's in the middle of Oklahoma. And yeah, we have this tool or a PDF file where you can see the rainfall data for the US. You can find it in our support center, support.optisurface.com. And yeah, you will have to find this article, step-by-step runoff analysis procedure. And there's a link there that you will see, this one. This will show you the rainfall atlas for the US. So let's click that. So yeah, it will open up the maps. So what you need is, what you're looking for is we usually use a 1 in 10 year. So I think that's around page 20. 1 year, 5 year, 10 year, 20, 10 years. So yeah. So around Oklahoma. So that would be around, I think this spot here. Yeah, so I think that's around, what's that, 2.6. This is 2.8. So yeah, I guess we can use 2.8. 2.8 for the storm. 2.8. And then for the 24 hours, I think that's in page 60. Here we go. So around this area, so between 5 and 6, that's around, I'd say 5.7, 5.8. Yeah, let's use 5.8. So go back here and use 5.8. And for the model, we will use the runoff coefficient of, yeah, 75%. Let's set this to cell sizing of 15 and restart the simulation. So yeah, you saw there's a peak flow there at around 2 hours. Yeah, you can click this one to show the maximums, and yeah, you will see the high velocity areas in there. So yeah, that's basically how you can run the water analysis for the ponding areas, the depressions, and the runoff analysis or the storm simulation here in AgEarth. So yeah, I hope that helps. Thanks.